Good morning, viewers. In today's class, we are going to see about nonlinear data structures, tree. Under tree, we are going to discuss about tree traversals. So it is in Unit 3. The subject name is CS8391 Data Structures. The objectives of this presentation are to learn about traversing of a binary tree. So we have three traversal techniques: in-order, pre-order and post-order traversal. So we are going to study about these three techniques with an example. Let's begin. So first, what is mean by traversing a binary tree? Traversing a binary tree is nothing but it is the process of visiting all the nodes in the graph, all the nodes in the tree exactly once. Okay, you have to visit each and every node in the tree exactly once. So that is called traversing a binary tree. Already we have studied two different types of data structure, linear data structure and the other one is non-linear data structure. Can you remember what is linear data structure? So here all the elements are stored sequentially, whereas in non-linear data structure, the elements are stored in random location. So for linear data structure, you can traverse the elements only in a sequential manner. But it is not true for nonlinear data structure. You can traverse the nonlinear data structure using many ways. The most three commonly used tree traversal techniques are in-order traversal, pre-order traversal and post-order traversal. First, what is in-order traversal? Remember the sentence left, root, right. Whenever you are hearing the word in-order traversal, immediately you should remember the sentence left, root, right. Now we are going to see an algorithm for in-order tree traversal. So first we have to traverse the left subtree. Then you have to visit the root node. Then you have to traverse the right subtree. That is like this. We are repeating the steps 2, 3, 4 until all the nodes are processed. As I told, initially you have to call the in-order traversal for left subtree. After finishing left subtree, you have to print the root node data. Then again the call, the same procedure in-order traversal for its right subtree. So this is the procedure for in-order traversal. The other name of in-order traversal is symmetric traversal, or you can say that LNR traversal algorithm. So what is LNR? Left node right. Nothing but left root right. We will see with one example. So consider we are given with one graph. The one tree. The root of the given tree is A, and under A we have two subtrees. The left subtree contains the elements B, D, E and the right subtree contains the elements C, F, G. So we are going to perform in-order traversal. So remember the sentence left, root, right. Okay. So as the sentence implies, you should not visit the root until its left subtree gets finished. So we move on to the left subtree. So for this left subtree, you have to apply the same condition, that is left, root, right. So before printing the root node B, you have to process its left subtree. So now the left subtree contains only one element D. So it is added in in-order traversal. After the completion of in-order traversal, you can display the root node data. Left, root, then right. So we come into the node E and E is added in the output. Now we have processed the left subtree. Once the left subtree gets finished, you can move to the root node. So the root node contains the element A. So A is printed. So now left subtree finished, root finished. So we move on to the right subtree. So right subtree contains the elements C, F, G. Once again, remember the sentence left, root, right. So before printing the root node data, you have to print the left node data. So it is F. So F is printed. Then we move on to the root node. So it is C. Once left and root gets finished, we come into the right node. So it is G. So that's all about in-order traversal. So initially, left node is printed D, then B is added, then E is added. With this, I have finished the processing of left subtree. I am moving into the root node. So A is printed. So with this, I have finished left tree and the root node processing. So I am coming into the right subtree. So again for the right subtree, you have to print left, root, right. So left is F and the root is C and the right is G. So this is the in-order traversal of the given tree. So why we are using this in-order traversal means it is used to print the non-decreasing order in case of binary search trees. So this is the use of in-order tree traversal. So we move on to the next traversal, pre-order traversal. So here remember the sentence root, left, then right. Okay. So the algorithm is first display the root, then traverse the left subtree, then traverse the right subtree. So the procedure is we are repeating the steps 2, 3, 4. So initially the root node data is printed. Then you have to call the same procedure pre-order for its left subtree. Then you have to call the same procedure pre-order for its right subtree. The other name of pre-order traversal is depth first traversal, or you can say it as NLR traversal. So what is NLR? Node, left, right. Nothing but root, left, right. Okay. Now clear? We are going to see one example. Again the same tree. So the root node is A. So now the order is root node first, then the left subtree second, and the right subtree third. Okay, so this is the order we are going to process the tree. So first root node is printed. So it is A. So A is printed. Once the root node is processed, you have to move into the left subtree. Okay, left subtree. But for this left subtree also, you have to apply the same condition, node, left, right. So now for this subtree, which one is the root node? It is B. So B is printed. Once the root node is finished, you have to move into the left subtree. So it is D. So D is printed. Then the right. So we move on to the node E. So E is printed. So now root gets finished and left subtree is also processed. So move into the right subtree. So right subtree is C, F, G. So again remember the condition node, left, right. So which is my root node? It is C. Then left node is F and the right node is G. So that's about the pre-order traversal of the given tree. Okay. So initially the root is printed. Then we move on to the left subtree. Again for the left subtree, remember the sentence node left right. So again the root node is B. It is printed. Then left is D. And then right is E. So now node is processed and left is processed. So we move into the right subtree. So again for this right subtree, remember the sentence node left right. So node is C. So C is printed and its left is F. So F is printed and finally G. Okay. So now can you understand what is pre-order traversal? So the uses of pre-order traversal are, it is used to create a copy of the tree, and also with the help of pre-order traversal, you can get prefix expression on an expression tree. Okay, you can able to get prefix expression using this pre-order traversal. So we move on to the next traversal techniques, post order. So remember the sentence left, right, root. So we will see the algorithm. Okay, left, then right, and finally the root. Okay, so traverse the left subtree, traverse the right subtree, and finally the root. So this is the order. So in procedure, we are repeating step 2, 3, 4. So initially left subtree is processed, then the right subtree, then we move with the root node data. So these steps are repeated until all the nodes are processed. So the other name of this algorithm is LRN algorithm. So what is LRN? Left, right node. Nothing but left, right and root. Okay. We will see one example for post-order traversal. Again the same tree, but now the order is left subtree is first, okay, and the right subtree is second, and finally the root node. Okay, so this is the order. So consider the sentences left, right, root. So before displaying the data, we move on to the left subtree. So for this left subtree also remember the sentence left, right, root. So left is D and right is E and finally the root node B. So now left subtree gets finished. So move into the root node. So don't display it. Before printing the root, you have to print its right subtree also. So now we are arriving at its right subtree. For the right subtree also remember the sentence left, right, root. So the left is F and right is G and the root is C. So left subtree, right subtree gets finished. So now we are arriving at the root and the root node A is also displayed. Okay. So before displaying the root node, move to the left subtree. For the left subtree also remember the condition is left, right, root. So before printing B, you have to print D. Then right, it is E. Then root, it is B. Then move to the right subtree. For the right subtree also initially left, so it is F. Then right, so it is G. And finally C. Now left subtree and right subtree both are processed. So move on to the root node. So root node data is displayed. So this is the end of post order traversal. So these are some sample gate questions. They will give you the post order traversal and the in order traversal, and they may ask you to calculate the height of the tree. So you have to formulate the tree using the given post order and in order. Then you can answer the question. So otherwise, they will give you the pre-order traversal and they ask you to write the post-order traversal. Okay, so these are some sample questions. They will give you one tree and they ask you to write in-order traversal sequence of the given tree. So that's about. With this, I'm completing today's topic, tree traversal techniques in third unit. Thank you all.